Wagwan, my GCSE science students, welcome back to another video. Now in today's video we're going to be looking at a chemistry paper 1 topic, chapter 6, which is electrolysis. Now in this video we're going to be going through the introduction to electrolysis. We're also going to be looking at the changes at the electrodes, the extraction of aluminium, and the electrolysis of solutions, which is dealt with by the higher content. Okay, now before we move on, make sure that you like, you share, you subscribe, and you're commenting below for anything that you don't understand. Okay, so let's look at the first bit, introduction to electrolysis. Now when you think about the word electrolysis, just think about that bit electro, which just means electricity. So you're using electricity, and the suffix lysis just means to split, to break something up. So electrolysis is by definition using electricity or an electric current to break up a substance. All right, and that substance is normally an ionic substance which can be molten or dissolved in water, and then when you break it breaks up into its different ions. Okay, so you can write that definition down. Now the ionic substance being broken down by electrolysis, that substance is known as the electrolyte, and you have two electrodes, your positive electrode, which is known as your anode, and the negative electrode, which is known as your cathode. Now to remember this, all right, you must be able to draw the diagram as well. So as you can see in your diagram, the negative end, that's your cathode, and the positive end, that's your anode. And if you have a look, your cations, which are your positive ions, so you can use the word cats to remember that cats have paws. All right, your positive ions, your cations, are attracted to the negative electrode, and your negative ions, your anions, are attracted to your anode. Okay, so in order to remember this, when you go into the exam, don't panic. Okay, so here's a mnemonic that you can use to remember this. So the positive electrode is called your anode, and your negative electrode is called your cathode. So if you get this to label, okay, so just remember, you're not going to panic. All right, why you're not going to panic? Because your positive electrode is called the anode, and your negative electrode is called the cathode. All right, so you'd never panic when you go into the exam. All right, so as we said earlier, the anions, which are negative, those are going to migrate towards the anode because opposites attract, and your cations, which are positive because cats have paws, okay, so cations are positive, those will migrate to the cathode. Okay, good. And the main reason for this is because opposite charges attract. Opposite charges attract. Okay, good. So that's a key point that you need to get from this. Now, when the cations go to the cathode, a reaction is going to take place, and you need to know what reaction is taking place. Okay, so when the cations go to the cathode, reduction is going to take place at the cathode. Okay, reduction is going to take place at the cathode, and when the anions go to the anode, oxidation is going to take place at the anode. Okay, good. So what exactly is oxidation? What exactly is reduction? Now, oxidation is the loss of electron. Oxidation is the losing of electrons. So this E minus here, that means electrons. Okay, all right, and reduction is the gain of electrons, and you could use the mnemonic again, oil rig, to remember this. Okay, so when you talk about oxidation and reduction, you need to know where it happens, and just remember the red cat, my big fat red cat. Now, why am I speaking about red cat? Because reduction will always happen at the cathode. Okay, now by reduction, remember, reduction means that you are gaining electrons. So remember that the cathode is negative. Okay, so your cathode is negative. So if I think about an example like sodium chloride, all right, and I split sodium chloride, I'm going to get two ions. Okay, I'm going to get my Na plus, and I'm going to get my Cl minus. My Na plus is going to migrate towards my cathode because opposites attract. When it goes to the cathode, it's not going to remain as Na plus. It's going to become reduced. And what do I mean by reduce? Reduce means that you're gaining electron. So it's going to gain 1 electron and it's going to change into your Na by itself. And this process is called reduction. This is the half equation for reduction. So that's a half equation for reduction. Okay. Now, still thinking about my same example, sodium chloride, my chloride ion, okay, let's just erase all on that slide. All right, my chloride ion from my sodium chloride is going to go to the anode. All right, and just remember my anorexic ox, okay? What does that mean? Oxidation is going to take place at the anode, which therefore means that my chloride ion, when it goes to the positive end, my chloride ion is not going to remain as chloride ion. It's going to change into Cl2. Now, straight away, what you need to realize is that this needs to be balanced. So Cl minus change to Cl2. I need to change that. I need to put a 2 in front rather to make sure that it is balanced. Okay. Now remember, oxidation means that you're losing electron. Oil rig, remember that it's losing electron, which therefore means that I'm going to lose 2 electrons on the right side. Now you're probably wondering, how did it become Cl2? There are a group of elements that they don't exist by themselves. They must appear in pairs. So these elements are as follows. Have no fear of ice cold bear. Okay, have no fear of ice cold bear. So hydrogen diatomic, nitrogen diatomic, fluorine diatomic, oxygen diatomic, iodine diatomic, chlorine diatomic, bromine diatomic. So remember, have no fear of ice cold bear. Those are diatomic, which is why it changed from Cl minus to Cl2. All right, so it now becomes Cl2. Now, if you need more practice of writing half equation, just comment down below and I can do a different video on writing half equation. Now, when you're thinking about electrolysis, you need to think about it in a table form like this. Okay, if you go in this order, it will help you to understand exactly what's going on. So let's look at our first example. I'm going to just do 2 examples because I want to keep the video as short as possible. All right, if we look at something like lead bromide, formula PbBr2. If you're not sure to write the equation, find my video on that formula, find my video on formula writing. So remember, in electrolysis, there are 2 electrodes. You have your anode and your cathode. So remember, we're not going to panic. Your positive electrode is called your anode. Your negative electrode is called your cathode. Okay? Now, inside lead bromide, there are 2 ions inside lead bromide. You have Pb2 plus, you have Br minus. Okay? So what's going to be happening here? Your 2 plus ion is going to go towards the cathode. Why is that so? Because opposites attract. The positive is going to go towards the negative, and which means that your Br minus is going to be attracted to the positive electrode, again because opposites attract. Now, when it gets to the positive electrode, when it gets to the negative, the positive, all right, scratch that in 3, 2, 1. Now, when the bromide gets to the positive electrode, to the anode, it's not going to remain as bromide. It's going to change into bromine, Br2. So just remember, have no fear of ice cold bear. Those elements have no fear of ice cold bear. These elements will always exist as diatomic, as a product, okay? However, lead will therefore change from being lead ion to now lead solid, okay? So it will now change to lead, all right? Good, just Pb. Now, how did that happen? Now remember, at the anode, Which process is always taking place there? Oxidation always takes place at the anode, and reduction always takes place at the cathode. So just remember, anox and red cat. Okay? So my half equation now, let's start with this easier one here. All right, what is meant by reduction? Oil rig. Reduction is the gain of electron. Reduction is gain of electron, which means it's going to gain 2 electrons to form Pb. Also, your bromide ion, how did it change to become Br2? It did this. Firstly, we have to balance the equation. So I have Br2 on that side, which means I need 2 bromide ions in order to do that. And oxidation is the loss of electron. Because you're losing it, it's the product of the reaction, and therefore there are the 2 electrons lost. Even though I'm putting a plus there, it just means that it is a product of the reaction. It's on the right side. Do you realize now that the 2 electrons which are lost by the positive electrode are those same 2 electrons gained by the negative electrode, which therefore means that electrolysis reactions are redox reactions, which means that oxidation and reduction are taking place at the same time. Okay, let's have another look at this. All right, let's look at calcium fluoride, CaF2 as my example. What 2 ions are going to be present in calcium fluoride? Ca2 plus as it's in group 2 and F minus as it's in group 7. Okay, so again, remind ourselves, positive electrode, what does that mean? All right, what's it called? So remember, we're not going to panic. So your positive electrode is called the anode, and your negative electrode is called the cathode. We're not going to panic. Okay, good. What ions are going to be attracted to the anode? Your anions, and in this case, your F minus is going to be attracted there, and your cations are going to be attracted to the cathode. So that's going to be Ca2 plus. What product is it going to form? It's going to form fluorine. What's the formula? Have no fear of ice cold beer. So it's going to be F2. Okay? And then what's this going to form on this side? It's going to form just calcium, not the ion. It's not going to be calcium metal. Okay? Good. Now this calcium metal, in order to write this half equation, is going to be F minus going to form F2. Alright, so now we need to balance that equation, so we need to put a 2 there. What process takes place at the anode? That process is called oxidation. Oxidation is the loss of electron, and I'm going to put those 2 electrons lost on the product side. Okay, let's go to the next side. So it's going to be Ca2 plus. It's going to gain 2 electrons. Alright, so it's the same 2 electrons which are lost on this side. It's going to gain 2 electrons, and it's going to form Ca solid, which therefore means that oxidation or reduction, oxidation always takes place at the anode, and reduction always takes place at the cathode, red cat. Okay, so once you're going through electrolysis, always just think about electrolysis in this way. All right, good. If you are foundation, or if you are not higher paper, you don't need to write the half equation. So this is only done by higher students only. All right, moving on. Now, what can happen? All these examples that we were looking at, these were molten examples. Okay. What happens now if we now dissolve the substance in water? Now, if we dissolve these substance in water, these ionic substance, you're going to have 2 extra ions present. These 2 extra ions are hydrogen ion and your hydroxide ion. So, for example, if you are looking at a sodium chloride solution, and this is the key word, that's how you're going to know that water is present. Once they use solution, it means that you now have 4 sets of ions present. You now have your sodium ions, you have your chloride ions, but these are the 2 extra ones, your hydrogen and your hydroxide ions. So now you have a total of 4 ions as opposed to 2 ions that we were looking at before, which therefore means that if we then switch our circuit on, What ions do you think are going to migrate where? Okay, you can pause the video and see if you get this right. All right, so what you should realize is that your hydroxide ions are going to go towards remember your positive is called the anode. So your hydroxide and your chloride is going to go towards the anode, and your hydrogen and your sodium ions are going to go towards the cathode. Okay, now you're now faced with a choice. How do you know which one is going to be formed at the anode, and how do you know which one is going to be formed at the cathode? Let's look at the cathode firstly. All right, so we're now looking, we have two ions here, sodium and hydrogen. How do we know which ion is going to be formed? The one which is going to be formed is going to be the less reactive. So how do you know which one is less reactive? You have to use your reactivity series. Okay, so your reactivity series is as follows. Please stop calling me a careless zebra. Instead, try learning how copper saved gold. Copper saved gold. All right. So this is your reactivity series. As you can see, hydrogen is there, sodium is there. We're going to choose the one which is less reactive to be formed. So the half equation that we're going to write here is your hydrogen, which is going to form H2. Remember, have no fear of ice cold bear. It would not be just H by itself. Therefore, we need to balance this equation. So we're going to put a 2 there. And remember, what process happens at the cathode? It is reduction, which means that you're going to gain 2 electrons. Okay, so that's the half equation there. That's the one that's we're going to write at the cathode. Okay, sodium will stay in the solution, but hydrogen, bubbles of hydrogen gas will be formed. And there is your equation for the cathode. Now, if you think about the anode, all right, how do we make that choice? Now this one is a little bit different. How do we know which one to choose? You're always going to choose the halogen. Okay, so if you have a halogen, meaning chlorine, bromine, or iodine, you're always going to choose the halogen, the halide ion as it's called. But I'm just going to use halogen to make it a little bit easier for you to understand. Okay, so if you have chloride and hydroxide, we're always going to choose the halogen. Okay, which therefore means that the half equation at this side is going to look like this. All right, your chloride ion is going to form chlorine and your 2 electrons there. Okay, it's just the rule. So to summarize the rule, if it is that you don't have a halogen, it is going to be the hydroxide. All right, that's just a rule that you need to know. So if it's not the halogen, it's going to be the hydroxide, and this is the equation formed at the cathode. Okay, the hydroxide will change into water and oxygen gas, and you will lose your 4 electrons. That's just a rule that you need to know. So to summarize the 2 rules, at the anode, if your negative ions, if you have a halogen or halide as they're called, the halogen is going to be formed. Okay, the halogen is formed. If you don't have a halogen, then oxygen is going to be formed. Because remember, if you don't have it, hydroxide is the one that's going to be formed. For the cathode, if your positive ion is anything above hydrogen, potassium, sodium, calcium, magnesium, zinc, or iron, then hydrogen is going to be formed because hydrogen is less reactive. However, if you have metals which are less reactive than hydrogen, then the metal is going to be produced. Okay, good. All right, so that's the rule that you just need to know for this. So let's put the rules in action. All right, so for example, these are all dissolved in water, which means that it is aqueous. All right, we're going to make sure that we understand the rules. All of these are aqueous. All right, hopefully that you, how do we know that they're aqueous? We know that they're aqueous because it says that it is dissolved in water. So what are my ions, my positive ions present in the solution? I'm going to have Cu2+, and I'm also going to have hydrogen. How do I know that hydrogen is there? Water is also there. And I'm also going to have SO4 2 minus from the sulfate. And I'm also going to have OH minus. Now, how do I know which one to choose? Remember your reactivity series. If you don't know the reactivity series, go and check my video on chapter 5, okay? So hydrogen is more reactive than copper. We always choose the less reactive. Therefore, copper is going to be formed, okay? Copper is going to be formed. All right. Now this side, do we have a halide? No, we don't have chlorine, bromine, or iodine, or we don't have chloride, bromide, or iodide. Therefore, we're going to choose the hydroxide, which therefore means that you're going to form oxygen and water. Okay. All right. So we could just put O2 and you also form water. Okay. We'll do one more and you can try the rest on your own. So calcium bromide. What positive ions are going to be present? You're going to have calcium. You're also going to have hydrogen. For the bromide, you're going to have Br minus, and you are also going to have OH minus. How do I know what's going to be formed at the positive electrode? Calcium is more reactive than hydrogen. If you're not sure, please check my video on the reactivity series. We choose the one which is less reactive. Therefore, you're going to form hydrogen there. And it's going to be H plus. All right. At this end, do you have a bromide? Yes, I do. Once you have a bromide, you always choose the bromide. Therefore, well, in this case, halide, okay, which is a bromide. So you're going to form bromine, okay, which is Br2. How do I know that? It's a halide. Chloride, bromide, iodide, anything that's in group 7, okay? You can try the rest on your own and comment below. Let me know if you're getting them right. Now, the final thing that we need to look at in terms of in terms of electrolysis is the extraction of aluminium. Now, aluminium comes from the ore which is called bauxite. Okay, so aluminium oxide comes from an ore which is called bauxite. All right, and it needs to be extracted and it needs to be split. So when you think about aluminium oxide, that's the formula. We only want the aluminium, okay? Now, what process do you think we use to do that? It's going to be electrolysis, okay? So the bauxite has to be broken up and processed into aluminium oxide to then become electrolyzed. Now, why do we need aluminium, all right? Why is it so good for better than steel? Now, aluminium is light. It's not as dense. Okay, it's quite light, and therefore, as a result of that, you can use it for packaging, as shown there. You can use it for making coins. All right, for making cars, aluminium foil, aeroplane, all right, bicycles, things which are resistant to corrosion as well. So aluminium doesn't corrode as easily, okay, because it forms a layer of aluminium oxide. Now, aluminium is much more expensive than steel to produce. However, it has a lower density, it has a high strength, which therefore means that the components made from aluminium will be lighter, stronger than their steel equivalent, even though it is expensive to produce, okay? So it's just that over time, it's going to be better than using steel. All right. Now, when you think about aluminium, look at the position of aluminium in the reactivity series. It's above carbon, which therefore means that you cannot use displacement to extract aluminium oxide. So if you try doing this and react it with carbon, that's going to be no reaction. Why? Because carbon cannot displace aluminium from its ore. That cannot happen. If you don't understand what I'm saying there, go and see my chapter 5 video, okay? So that cannot happen. Therefore, anything found at the top, we're going to use electrolysis, okay? We're going to use electrolysis to extract these, okay? So we then spoke about the position as to why it cannot be extracted using the displacement reaction by carbon, okay? See my video on chapter 5. Now, an ore, as we mentioned in my chapter 5 video, is any rock that contains enough metal for it to be extracted economically. Now, how is this done? This is done in a process called the Bayer process. Now, the Bayer process just means that you crush the ore, you remove the sand, you dissolve the aluminium compounds, you heat it so that it's molten, so that you can then carry out electrolysis. Okay, so step one, it's purified. Okay, so 3 tons of bauxite, fun fact, actually make 1 ton of aluminium oxide, which you can see is a solid. But if we try to carry out electrolysis on this, it's not going to work. And the reason it's not going to work is because the ions are not being able to move, therefore we need to melt it. Now, as you can imagine, this compound is an ionic compound. How do I know it's ionic? Because it's a metal bonded with a non-metal, which therefore means it's going to have a giant ionic lattice structure. Okay, it's going to have a giant ionic lattice structure, which therefore means you're expecting it to have a very high melting point. Okay, the melting point is going to be extremely high, and the formula is Al2O3. Now, because the melting point is extremely high, if we try to melt this, you're going to require a lot of energy, enormous amount of energy. Now, in order to lower its melting point, we use a substance which is called cryolite. Now, you don't have to know the formula, but this formula is just there for you to understand it. Now, aluminium oxide, when you dissolve cryolite inside of it, it lowers the melting point all the way from about 2050 degrees Celsius all the way down to roughly about 900 degrees Celsius. So that's roughly cutting its melting point into a half. So you're saving lots and lots of energy. All right. Now, after it's molten, we then carry out electrolysis. Now, this is what it looks like. This is the setup, and you need to be able to draw this. In the electrolysis of aluminium oxide, you can see here the negative end. Remember, the negative is the cathode. All right. And you can see the positive end. The positive end is the anode. Okay, so if you pass electricity through aluminium oxide, it's the aluminium ions are going to migrate to the cathode, so the Al3 plus. They're going to gain 3 electrons, and it's going to form aluminium. And that aluminium here, which is attracted to the cathode because it's less dense, it can be tapped off. Now at the anode, your oxide ions, your O2 minus, what will happen? It will then form oxygen gas, and then we need to balance that equation, so we're going to put a 2 in front of that. Okay, and remember, oxidation always happens at the anode, anox. So it's going to lose, each oxide is going to lose 2 electrons, so it's going to lose a total of 4 electrons. Okay, now this oxygen, which is produced at the anode, that oxygen can combine with the carbon positive electrode. Okay, so what will end up happening is that the carbon electrode, which is the graphite, will react with the oxygen which is produced at the anode, and then it forms carbon dioxide. Now you can see the bubbles of carbon dioxide gas coming off there, which means that over time this carbon electrode is then broken down and has to constantly be replaced. So this is another reason why this process is so expensive. Okay, so let's look at these final questions before we end off. Why does the aluminium end up at the bottom of the tank? Because the aluminium is less dense. It's not a very dense substance. Why are we making carbon dioxide? Because the oxygen which is produced at the anode, okay, that oxygen gas will then react with the carbon positive electrode to then form carbon dioxide. Okay, and what problem will that cause? It means that we constantly have to replace the graphite electrode. Okay, so aluminium is expensive because a lot of energy is required to carry out this process, and also you have to constantly replace the electrode. Now that summarizes almost, well, everything that you need to know for this chapter. Okay, remember to like, share, and subscribe, and all the best in your GCSEs. I am out.